x square d square minus 3xd plus 4 into y equal to x square cos log x. Okay, so this is the differential equation with the variable coefficient. Cauchy's or Euler's equation. To solve this differential equation, we have to convert this variable coefficient to constant coefficient by putting x is equal to e power z implies z equal to log x. So then it will be converted into xd is d dash, x square d square is d dash into d dash minus 1. When you multiply d dash inside, d dash square minus d dash, where d dash is d by dz. Okay, by substituting this value here, it will be converted into constant coefficient. So listen, x square d square. What is x square d square? X square d square is d dash square minus d dash. So d dash square minus d dash minus 3 into xd. xd is d dash plus 4 into y is equal to x square. What is x square? X square is e power 2z into cos log x. Log x is z. So now you simplify d dash square minus 4d dash plus 4 into y equal to e power 2z into cos z. Now this is the differential equation with the constant coefficient, and we can solve as usual. But the particular integral is type phi. This is type phi, e power ax into v model. Okay, now first I am going to find out the complementary function. For that I am going to form auxiliary equation. What is auxiliary equation? M square minus 4m plus 4 equal to 0. To solve this differential equation, 4 is minus 2 into minus 2, add minus 4. So this is become m minus 2 into m minus 2 equal to 0. So m is equal to 2 and m is equal to 2. Both are equal roots. Equal root mean the complementary function is a z. Instead of x you have to write z because we are converted into in terms of z. So ax plus b is x is z. A z plus b into e power mz. So this is the formula. Here m value is 2. So the complementary function is az plus b into e power 2z. So this is the complementary function. This is the complementary function. Next I am going to find out the particular integral. Okay, next I am going to find out the particular integral. So pi is equal to 1 by d dash square minus 4d dash plus 4 into e power 2z into cos z. So this is already type phi. In this type phi, e power ax into v. So here we have to replace d dash is replaced by d dash plus coefficient of z is 2. So replacing d dash by d dash plus 2. So after replacing this, e power 2x keep here. E power 2z by 1 by d dash is replaced by d dash plus 2. So here d dash plus 2 the whole square minus 4 into d dash plus 2 plus 4 into cos z. Okay, now e power 2z 1 by, apply a plus b the whole square formula, a square plus b square plus 2ab, and now multiply minus 4 inside, minus 4d dash minus 8 plus 4 into cos z. Okay, now I am going to simplify. E power 2z 1 by, you see this and this cancel, plus 8 minus 8 cancel, only d dash square term outside, d dash square term outside, denominator into cos z. You see, this is the what, type 3. In type 3, d square is replaced by minus a square. So d dash square is replaced by minus a square, but a is 1, coefficient of z is 1, so that it is minus 1. So replacing minus 1 here, e power 2z 1 by minus 1 into cos z. So finally the particular integral is minus e power 2z into cos z. So this is the particular integral. So finally the solution is Solution is y equal to CF plus PI. So y is equal to CF is AZ plus B into e power 2z, and the particular integral minus e power 2z into cos z. So this is a solution, but the solution in terms of x. So where z equal to log x. So that here you have to mention where z equal to log x. So answer must be in terms of x. So this is the solution of the given differential equation.